Unit 8 is going to be oversimplifying rational expressions, okay? So, what a rational expression is, it is just a fraction of two polynomial expressions, okay? So, to simplify these, we must first factor, okay? So, we first check for a GCF on the top, check for one on the bottom, okay? These are two separate sides of a fraction, so that means two separate factoring problems. And then if we're able to, we will reduce what we call monomial terms. That comes first, okay? What a monomial term is just a singular term, one term. So for instance, a monomial could be just x, right? That would be a monomial, because it's just one term by itself. 4x would also be a monomial, because it's still one term altogether. Do we all see that? Okay, but if I, for instance, had 4x plus 2y, well, now I got two terms. Okay, so that would be what we call a binomial. So after we've reduced singular terms, we then can reduce common binomial terms. So for instance, a binomial would be like 4x plus 2y. Okay, so two terms. You can only reduce binomial terms that are exactly the same. So they have to be the exact same. And we'll talk about what that means here in a minute. Okay. So, we're going to start off by looking at example 1. Okay? So if I look at the top of this fraction, how many terms do I have? 1. Okay? So we call that a monomial term. I have one term. Okay? What about the bottom? Also 1. Okay? Perfect. So when we have these monomial terms, we treat them just like simplifying any regular fraction, okay? So we first look at just the numbers. So 15 over 3, can that be simplified? Yeah, what can I take out? A 3. So if I divide both of these by 3, it becomes 15 divided by 3 would be 5, so that would become a 5, and 3 divided by 3 would be 1. Perfect. Okay, then I have x to the 6th over x to the 4th. Are those the same base variable? Yeah. Like the base, so x. They both have x? Okay, perfect. So when we have bases that are the same, what are we allowed to do with those exponents if we're dividing? Anybody remember exponent rules for this? If the bases are the same and you're dividing, you can actually subtract the exponents. Anybody remember that? So we can do 6 minus 4, and what would that give us? 2, okay? So this would just be x squared on top. 6 minus 4 is 2, and that 2 stays on top. So then our final answer is just 5x squared over 1, or just 5x squared. Questions on that? Okay. And then we go to example 2. All right. Example 2, what do we have on top? A monomial or a binomial? A binomial. And what about on bottom? A binomial, okay. We look, can either one of them be factored? Meaning, is there a GCF I could take out on the top or on the bottom? Yeah? What? 3 on the top. Do we see that? 3k minus 12, we could take out a 3. And what's going to be left inside if we divide by 3? So k minus 4. Can anything be taken out of the bottom if it's just k minus 4? No. No GCF there. Okay. So now, on top, I have a monomial and a binomial, right? And on bottom, I have a binomial. Everything is completely factored. So now what I'm allowed to do is if I had a monomial on bottom too, I could simplify those if possible, but I don't. So I just look at the binomial terms. Are they both the exact same? So we can cancel them. Only because they're the exact same.
So what did you just say?
And it would just be 3. Yep.
This all seems too good.
No. Okay. Question on that? All right, we're almost done. Last page of notes. Okay. On top, how many terms do I have? 2, and can it be factored? No. On the bottom, how many do I have? I have 3. How do we factor that? X method. Woohoo! You remember. Okay, so we draw an X. This class is so fun. Thank you, Timmy.
Trying to lift the spirits.
Good, we need that. What's going to go on the top of the X? Not 2. 1 times negative 24 is? Perfect. What goes on the bottom? 2. So 2 things that will multiply to negative 24, add to 2. 6 and 4.
So we'll have to do negative 4 and 6.
Yep. Negative 4, positive 6. I like it. Since this A value, this first value is a 1, that means I can use the shortcut on this, right?
Yeah.
So my 2 factors are just X plus 6 and X minus 4. So that's the other one. Yep. Just these 2. Okay. So what I have right now is I have X plus 6 on top, and then I have X plus 6 times X plus 4 or X minus 4 on the bottom. Do we see anything that might happen here?
You gotta combine X plus 6 and X minus 4.
We're not going to combine them. We just unfold them.
You can
Cancel them, yep. So what I have then, I have an X minus 4 on the bottom. What do I have left on top?
0, nothing.
We have nothing, okay? But if it was a 0, then this whole thing would go away, okay? So we actually have a 1. That's it. Okay?
Ooh.
This looks fun. Okay. What'd you say?
I said 3 can go in all those.
3 will go in the top.
Yeah.
What's going to be left?
X squared minus X minus 1.
Cool. Is that factored completely?
No, the bottom.
Oh, the bottom?
Well, which? I mean, you can use 6 for the bottom.
You can use 6 for the bottom?
X minus 5.
Okay. So now we look. So with the top, we have 3 times a trinomial. Is that trinomial factored?
Yeah.
Mm,
No.
no. What do we have to do with that?
We gotta break that down. Right. Triangle.
I wouldn't do quadratic formula, no. But if you wanted to, you could. But we can just do X method. What's going to go on the top? Negative 20. What's going to go on the bottom? So 2 things that multiply to negative 20, add to negative 1.
5 and 4, but
5 and 4, but
5 and negative 4? No, negative 5 and 4.
okay. Negative 5, positive 4?
Yeah.
Good.
I'm about to say.
So on the top then, that's going to become 3 times my 2 factors, which are
Negative, well,
X
X squared.
x minus 5, and x plus 4. Okay, again, since this is leading term here, inside is a 1, that's the reason I can use that shortcut. Most of the time I would have to do factor by grouping, right? If it wasn't a 1. Okay. And then on bottom I have 6 times x minus 5.
Maybe you cross out that x minus 5 on top.
Yeah, the x minus 5s are going to cancel. Is anything else going to happen?
No. I mean, 3 can go into 3 and 6.
So 3 and 6 are monomial terms, right? So just like number 1 that we did, we can simplify monomials. So 3 divided by 6 would be what? 1 over 2. Okay. So 1 times x plus 4 divided by 2. Is that as simple as it will go? Yeah. Because we cannot simplify a binomial with a monomial.
Okay, this is not as bad as I thought.
It's really not.
Pretty easy. I know, but this one's actually not that bad.
I'm gonna be honest,
You don't think you can do it by yourself? Well, too bad. Okay, last but not least, number 5. I want you to change the bottom to say 5 plus r. 5 plus r.
I'm looking at it. I don't want to look at it.
I want you to go ahead and try this one.
Oh, yeah.
We changed it to a 5 plus r. Finally,
That's it?
r minus 5r plus 5. It was on our last test. Come on.
I pretty much had that. I'm gonna jump out that window.
You should. No, I'm kidding. Don't.
Oh. Okay.
Don't do that. Okay, so we break it down. R minus 5r plus 5 over 5 plus r. So now we look. Do we have any binomials that are the exact same?
Yes.
What are they?
Well,
Aren't they though? If I had 3 plus 2 and 2 plus 3, wouldn't that be the same thing?
Same thing, yes.
It is the same thing.
Exact same thing.
so it's just r minus 5.
It is the exact same thing. You're still adding them. 5 plus r is r minus.
It's not the same. Are you kidding me?
Say what?
Is this just r minus 5?
Yeah.
Oh my god, that went down.
I know, but you didn't do the right work.
Okay, that's not the answer.
But
An answer's an answer.
it doesn't mean that you knew how you got there.
It's correct, yeah.
Okay.
I know how I got there.
Last thing I want to talk about real quick. I am going to add an example 6.
Why would you do that?
Back to what it originally was.
Okay.
Okay, so the same thing, we'd break down the top as r minus 5, r plus 5, in whichever order, over 5 minus r. Okay? So now, if I look at these, do I have any binomials that are the exact same?
Yeah.
Technically, no. Okay? Because r minus 5 and 5 minus r are not the same thing.
Really?
Because subtraction's not irreversible. So for instance, 3 minus 2 and 2 minus 3, are those the same thing? No, they're not. Yeah, okay. So when I have this, there is a special case, and this is the only time that you get to cross off binomials that are not the exact same. This is the only time, and we got to write this rule over to the side, so make sure you have room. If you drew me a pretty picture somewhere, draw this somewhere where there's no pretty picture, okay? There is a rule called a minus b over b minus a equals -1.
So technically it'd just be -1 in general, I guess, right?
No, it would be
Huh?
r plus 5 over -1.
So you can cross off r minus 5 and 5 minus r and make that just a -1 times r plus 5. And that's my answer. Okay?
Good notes today.
Do you want to see why that rule works?
No.
You don't have to write it, but I want to explain it.
us, yeah.
Okay, I want to show you. And then, Timmy, you can go to the bathroom for 30 minutes, like you always do.
When was the last time I went to a bathroom?
I'm kidding. Okay. So, here's why this works. You can pick any two numbers or any two variables. So pick two numbers, random ones.
7 and 8.
7 and 8, perfect. Okay.
Like 9 or
So A is going to be 7 and B is going to be 8, all right? So if I do 7 minus 8 over 8 minus 7, what is 7 minus 8?
negative 1.
What's 8 minus 7?
1.
What's negative 1 divided by 1?
Negative 1.
Okay. Doesn't matter what you pick. Whatever you pick, that'll work. Okay? Any questions on that?
Cool.
Okay, that's it. Delta Math homework.
Oh my